Hi, welcome to this physics video. In this video, we will learn some properties of fluids at rest. So let's begin. Objective in this video is to define Pascal's principle. And number two is to explain how the pressure changes with depth. The keywords are fluid, the meaning is liquid or gas. Principle, the meaning is ideas or theories. This principle is different than the principle, school principle. This principle has meaning which is idea. Now the depth is deepness. How deep? For example, how deep inside water? How deep inside the sea? So first topic was Pascal's principle. Boys, Pascal was the name of the scientist, and he gave an idea which is known as Pascal's principle. So it says a change a change in pressure to any point in a fluid inside a closed container. So this principle is about fluid, and the fluid must be inside a closed container like this. You can see this container is closed, this vessel is closed. Now, so a change in pressure to any point, if you apply a pressure, for example, at this point you apply 5 Pascal pressure. So same change is felt in every point, like this point also you feel same change, 5 Pascal, here 5 Pascal, here 5 Pascal, here 5 Pascal. So that's what it writes, is that a change in pressure to any point in a fluid inside a closed container is passed to every point in the fluid and the walls of the container. Same change in the pressure is felt at every point in the fluid and in the every point in the wall of the container. We can say simply same Pascal's principle, we can say simply here, like a change in one part of the fluid brings same change in all other parts. Similarly, I mean, these two definitions are similar. This is a little in detail and this is briefly. Now, the next topic is pressure in a fluid. In this slide, we will learn how pressure acts in a fluid in different points. So this is a container, as you can see. There are 3 holes, one at different points, point A, point B, point C. So the pressure P at any point in a fluid depends on 3 things, boys. 3 things it depends. Number 1 is depth of the point, which is H. Number 2 is the density of the fluid, which is rho. See, this is rho, not P. See, looks like P but reads rho, which is used for density. Now the third is G, gravity. So I repeat, pressure P in a fluid depends on 3 things. Number 1, depth H. Number 2, density. Number 3, gravity. After we combine all these 3, Can we write the formula of pressure in a fluid like this? P equals rho times H times G. P equals rho multiplied by H multiplied by G, where rho is density of the fluid, H is the height or depth of the fluid, and G is the gravity, which is 9.8. So this is further explanation of the previous formula, which is P equals rho Hg. Boys, if H increases, then pressure also increases. You go further deep in the sea, you will feel more pressure. You come up in the sea, you will feel less pressure. Now, if H, as I said, depth is low, pressure is low. Now the density of the fluid also is a factor which affects the pressure. If density is high, increase more, pressure is more. If density is less, then the pressure is less. Here is the example. This has oil and this container has water. In which container there will be more pressure? In container A, there will be more pressure. Why? Because the oil has more density than the water. As you know that if density is more, pressure is more. Here is a question. Four balls are at depths of 1 meter, 2 meters, 3 meters. Where is the pressure the greatest? See guys, you have three balls inside water. Ball A, ball B and ball C. Which ball has the greatest pressure? That's right, the C, ball C, because the depth is more here, the deep is more here. It is 3 meter. Here the pressure will be the minimum, very the smallest pressure here. Here is an example question. Calculate the pressure exerted by water at a depth of 100 meter. Water has a density of 1.0 times 10 power 3 kg per meter cube. Now we will analyze this question. The step one, as we already discussed in other videos, that the step one of solving of a question is to write the numbers given in the question. So in this question, the numbers which we see is depth h. You can see here depth h is equal to 100 meter. If I can highlight this one, will be helpful for us. Depth is 100 meter. Density 1.0 times 10 power 3 kg per meter cube. What we need pressure. So must we need to highlight these things. So this is given. We write the numbers from the question. H equals 100 meter, rho equals 1.0 times 10 power 3. Remember, rho is density, H is depth. Now, next step is to write what we need to find. So we need to find P, pressure equals question mark. This question mark reminds us that we need to find pressure. Now next step is to solve, and in this we will write first the formula or the law, simply the formula. So P equals rho GH equal, how much is the rho? Rho is of course 1.0 times 10 to the power 3 times how much G? G is 9.8, and then comes H. H is how much? 100. So we get, after multiplication of all these numbers, 9.8 times 10 power 5 Pascal. Thank you and have a nice day.